Good morning, everyone. I welcome you all to this session of hands-on experience. Today, we are here in the Department of Ocean Engineering. Of the various test facilities we house in the Department of Ocean Engineering, IIT Madras, we are presently in the 4-meter deep water wave flume. The dimensions of the deep water wave flume are 90 meters in length, 4 meters in width, 3 meters in depth. In this hands-on session experience, we are not going to generate any waves as against the previous class, wherein in the glass plume we generated the waves to see the wave structure interaction happening with the oscillating water column. Today we are going to see about the free decay oscillations of a floating structure, preferably the semi-submersible, which one of my students is working on, Mr. Rushikesh. The model is 1:40 scale ratio. So here you can see it in the back of me, the scaled model. The idea of today's experiments is that we are interested in finding out the natural periods and the damping ratio of the floating structure. Why should we calculate this? Because this has to be known priori. It depends on the application. For example, in the case of floating offshore wind turbines, we want to choose a floating structure such that the natural periods are away from the operating zone, which means, for example, for a given site somewhere in Indian coast or somewhere, if the most probable wave height is say 18 seconds, we want to design a structure such that it is far away from the most probable wave period. So that is the idea. This experiments is primarily aimed at finding out experimentally to ascertain the numerical calculations that we do priori. Fine. So different modes that exist for a floating structure, 6 critical modes are there, in which we are focused on 3 critical modes, primarily the heave, roll and the pitch. Why are we preferring these things? Because these things are greatly responsible for the stability of a floating structure. So in a nutshell, today's hands-on session experience will be focused on finding out the natural periods and the damping ratio of a floating structure based on the free decay test. So the free oscillation test that we mentioned basically refers to the free decay test that we are planning to do today. So how we do? Primarily we have a floating structure. We deliberately give some force and impulse loading to the floating structure in the critical mode. For example, in the heave, in the vertical direction only. Then we see the responses, and based on the free decay, how it is varying over a period of time, and then we see the logarithm decrement curve, and then we find out the natural period. First we find out the damped natural period and then the natural period. As we said earlier, in the present session, we are focused on free decay test. So we need the data. So how are we getting the data? For this, we are using the motion response unit, which is an MRU. These days, it has come as a very sophisticated device. 10 years back, we used to use accelerometers to get the different values, but then this MRU is a package in which all the data you will get it at one shot, which means all the 6 degrees of freedom of a floating structure you can get it at one shot. That is what. So this MRU is mounted on top of your semi-submersible on the deck, wherein no water contact is made, and in some structures wherein if there is a water splashing onto the MRU, we coat it or we protect it with some kind of a plastic coating. Here you can see our semi-submersible placed in the center of the wave flume. MRU is mounted on top, on the deck what we call, and MRU is connected to the PC, and wherein you can see the behavior. Now we are going to give a stroke length based on which the responses will be recorded in the PC, and that will be post-processed to find out the natural period and the damping ratio. Before we do it, the floating structure is deliberately placed in the middle, primarily to avoid any reflection from the wall when the waves are generated because of the oscillation which we give to the floating structure. Now our scholar deliberately gives a stroke in the heave direction, and whose data will be recorded in the software. So now we are giving an impulse loading to our floating structure semi-submersible, and because of the MRU, we are able to see the readings in our dedicated software, and this data will be post-processed to find out the damping ratio and the natural periods. Earlier you have seen the heave motion, wherein we have given the stroke in the heave direction. Now we are going to deliberately give
a roll motion, because of which waves will be generated. The waves will be generated in any of the cases, whether you give the stroke in the heave or in angular motion in the roll and pitch as well. Now, our student, our scholar, Mr. Rushikesh will give the roll motion. Now, you can see the structure is oscillating, and because of the oscillation, the waves are generated. The waves generated is so small that we may not be able to 100% see it, but because of that, the structure is coming to rest very quickly. Now, with this free decay curves, we will be able to find out what is the natural period of the structures. Thank you.